Welcome back, everyone. Today we're going deep on Apache Kafka. You might have heard of it, even if you're not a hardcore techie, because it's everywhere behind the scenes.
Absolutely. Kafka is this powerful tool in the world of data. Today we'll try demystifying it. We'll start with the basics and then talk about how it's used in real-world scenarios.
I'm looking forward to that. So, to set the scene, can we talk about event-driven architecture first? I know it's kind of a techie term. How would you explain it simply?
Okay. Imagine ordering like food online. You hit that place order button and a bunch of things happen, right? Your card gets charged, the restaurant gets the order, and the chef starts cooking.
Right, and then I get that notification that my food's on the way.
Exactly. Each step is like an event that triggers the next thing. That's event-driven architecture in a nutshell.
Okay, so it's actions causing a chain reaction, like dominoes.
Yeah.
So then where does Kafka fit into all of this?
Kafka's like the conductor of this whole event orchestra. It makes sure each event or message gets delivered to the right spot at the right time super efficiently.
So it's kind of like a high-tech postal service for the digital world, making sure all the mail is sorted and delivered correctly.
Yeah, a very fast and organized postal service.
Awesome. So we've got these events happening, but how does Kafka actually handle all this information? YouTube video 3, Apache Kafka Fundamentals, talks about producers, brokers, and consumers. Can you explain?
Okay, imagine a busy market. Producers are like farmers bringing their stuff to sell. They create those events or messages in the Kafka system.
Okay, and then brokers would be like the vendors with their stalls.
Yeah, they get the messages from producers and make them available for consumers.
Gotcha. So the consumers are like the shoppers, right? Looking around and picking what they need.
You got it. Consumers are the ones actually processing the messages. Let's say you're tracking stocks. You might have a consumer looking for messages about certain stocks, like the ones you care about.
That makes sense. Now, 4. How Kafka Works mentions these things called topics, partitions, and logs. It sounds very technical. Are they just fancy names for labels, shelves, and inventory lists in our market example?
Pretty much. Topics are like categories, like fruits, veggies, and so on. Partitions divide those categories further, like organizing a stall into sections. The log, that's like an inventory list. It records every piece of produce, so every single message.
So Kafka's neatly organizing messages so consumers can find what they need. But that video also mentioned that messages in Kafka are immutable. What does that even mean, and why is it important?
Immutable means once a message is in the log, it's set in stone. Think of it like a historical record. Every event is permanently recorded. That's important for data integrity.
Makes sense, especially if it's sensitive stuff like financial transactions or health records. You wouldn't want any accidental or malicious changes.
Right. And it also makes Kafka crazy efficient. Instead of updating stuff all the time, it just adds new messages to the log. Super fast for reading and writing, which is perfect for real-time applications.
That's so clever. Okay, so we have producers making messages, brokers storing and sorting them, and consumers taking the info they need, all in a system where messages are categorized and can't be messed with. It's a pretty efficient system, right?
Yeah, it's like a well-oiled machine built for speed and reliability, and this is just the beginning. Kafka can handle huge amounts of data, which is why it's used in things like real-time analytics, streaming platforms, and all sorts of cool stuff.
This is already way clearer than I thought it'd be. I'm curious about how these concepts actually play out in the real world. Like, how are companies using Kafka to actually solve problems?
Yeah, let's get into some real-world examples. Netflix, for example, they deal with a crazy amount of data. Every time someone watches something, there's like playback, recommendations, subtitles. The cloud-native and scalable Kafka Architecture video shows how they use multiple Kafka setups to handle it all.
That's mind-blowing. So many things happening at once. But why use Kafka? Couldn't they just use a regular database?
Regular databases are good for storing data, but they're not built for the speed of real-time streaming. Kafka is made for that. It can process tons of messages per second.
So it's like the data superhighway, keeping things moving smoothly, no traffic jams.
Yeah, exactly. And it's not just for streaming movies. Kafka on Kubernetes, from evaluation to production at Intuit, shows how Intuit, the company that makes TurboTax, uses Kafka for all their financial data.
That's pretty different from Netflix.
Yeah.
What were some challenges Intuit had, and how did Kafka help?
Well, they needed a system that could handle millions of transactions securely and reliably, and it had to make sure the data was consistent across all their products. Kafka's distributed architecture and security features were perfect for that.
So Kafka helped them streamline their data and make things better for their users. But scaling any tech, especially at that level, must be tough. Diving into Kafka internals with David Jacotte and cloud-native and scalable Kafka architecture, touch on that. What are the big hurdles companies face when they need to scale Kafka?
One of the biggest is availability. If Kafka crashes, even briefly, it can mess up everything. Imagine Netflix going down during a big show premiere. That'd be chaos.
Total disaster. Millions of people suddenly can't watch their shows. How do they avoid that?
Well, they use things like replication, basically making copies of the data and putting them on different servers. If one server fails, another one takes over.
Like having backup generators for when the power goes out. Smart. But replication sounds complicated. How does Kafka keep all those copies in sync?
That's where leader election and ISR in-sync replica come in. For each partition, Kafka chooses a leader, which handles the read and write requests. The ISR tracks which replicas are up to date and ready to step in if the leader goes down.
So it's like a mini democracy inside Kafka, with a leader but others ready to take charge. That's really cool.
Yeah, it's all about keeping the data safe and accessible. Super important for companies like Netflix that need to be up and running all the time.
Makes sense. Okay, so I'm getting a better picture of how Kafka works in a real-world complex setting. But one thing I found interesting was the idea that Kafka isn't just for real-time streaming. Ido Nadler and Ofer Dubrovsky, should you read Kafka as a stream or in batch? Should you even care? Made that point about batch processing. Can you explain that a bit?
A lot of people think Kafka is just for streaming, but it can do batch processing too. That's like processing large chunks of data at specific times, not constantly.
So it's a different approach, doing it in batches instead of continuously. Why would someone use Kafka for that instead of a traditional batch system?
Well, Kafka can do both streaming and batch processing together. That makes things simpler. And Kafka can replay messages from any point, which is really useful for batch jobs.
So a company could process data in hourly or daily batches, which might be better for certain situations?
Yeah, like Intuit actually switched to hourly batch jobs, and it saved them a ton of money on infrastructure.
Wow, that's pretty clever. They get the benefits of both worlds. But I'm guessing there are things to watch out for when using Kafka, right? It can't all be smooth sailing.
Definitely. Implementing Kafka in a real company setting needs careful planning. The lessons learned from Kafka in production, Tim Berglund, Confluent, and event-driven architectures done right, Apache Kafka, Tim Berglund, Devox Poland 2021 videos give some great advice on how to avoid common mistakes.
So, what are some key things to remember? What can save our listeners from some headaches?
Schema management is a big one. Just because Kafka handles unstructured data doesn't mean you can ignore data structure. It's like building a house without blueprints. It won't end well.
Yeah, you need a solid plan. So schemas are like the blueprints for data in Kafka, making sure everyone's on the same page.
Exactly. They ensure that messages are formatted correctly so consumers can understand them. Without schemas, it's chaos. Messages get misinterpreted, data gets corrupted.
Gotcha. Schemas are key. Any other pitfalls to watch out for?
Testing and deployment are also critical. The lessons learned from Kafka in production video talked about a company that messed up their partition reassignment in production because they didn't test their scripts properly.
Ouch. So testing is crucial.
Absolutely. You need to understand your Kafka setup and test thoroughly before going live to avoid surprises and downtime.
Okay, so we've covered a lot. We started with event-driven architecture, then talked about Kafka's role, the challenges of scaling it, and how to avoid some common mistakes.
Yeah.
I have to say, Kafka is really impressive. But before we wrap up, I'm curious about something. The diving into Kafka internals with David Jacotte video got me thinking. Could Kafka, with its massive data storage and those immutable logs, actually become like a database itself someday?
That's an interesting thought. Kafka isn't a database in the traditional sense, but it has some database-like features, like it can store and retrieve data using keys, similar to a key value store.
So you're saying there's a chance Kafka could become this hybrid, a messaging system and a database in the future?
It's definitely possible. We're already seeing things like KSQLDB, which lets you use SQL-like queries on Kafka streams. That's blurring the lines between messaging and databases even more.
That's wild. Who knows what the future holds for Kafka?
Technology is always changing. Kafka's got a great architecture and a strong community, so it's well-equipped to adapt and shape the future of data.
This has been a really eye-opening look at Kafka. We went from the basics to the really complex stuff, from how it works to how companies are using it, and even its potential future.
Yeah. I feel like I actually understand Kafka now, which is Pretty impressive. It's amazing how much it does behind the scenes. But before we go, let's recap some key takeaways. What really stood out to you?
Yeah, good idea. A quick recap can be helpful. So what are some of the big things you learned?
Honestly, the whole event-driven architecture thing was a light bulb moment for me. How actions can trigger all these other things. It's like a hidden network connecting everything in the digital world. I agree. Event-driven architecture is a big deal, and Kafka's right at the center of it. It helps create these responsive, scalable, and resilient systems.
And how Kafka organizes everything with the topics, partitions, and logs. It's so smart. And the fact that messages can't be changed, that's huge for keeping data safe and efficient.
Yeah, it's a brilliant system built for handling the massive amounts of data we have these days.
We also saw how companies like Netflix and Intuit are using it to solve real problems. From streaming movies to managing finances, it's incredible how versatile Kafka is.
Definitely. Kafka's not just some niche thing. It's a fundamental tool for any company that relies on data.
But we also learned that it's not like a magic bullet. Scaling Kafka can be tough, and you got to be careful. Schema management and testing are super important if you want to avoid problems.
For sure. Kafka is powerful, but you need to understand it and use it wisely.
And then there's that question about Kafka maybe evolving into a database someday.
Yeah.
It's mind-blowing.
Yeah, it's really interesting to think about. It shows how flexible Kafka is and how creative the community is. Who knows what the future holds?
That's the exciting part. Well, that wraps up our deep dive into Apache Kafka. I hope everyone listening has a much better understanding now. And if you're curious to learn more, go for it. There's tons of information out there.
And remember, we've just scratched the surface here. Kafka's world is huge and constantly changing, so keep exploring.
Absolutely. Until next time, keep learning and keep those data streams flowing.